Welcome to qnawire.
In the first item, we have to calculate the acceleration of the lighter block in this first situation. So for that, we have to use Newton's second law. And for that, I will use a weird reference frame, which is this one. This is my axis. Okay, then using this crazy reference frame, let us solve this question. So let me say that this lighter block is block number 1 and the heavier block is block number 2. Applying Newton's second law to block number 1, we get that the net force is equals to m1 times A. But the net force acting on block number 1 is composed by two forces, the tension pointing to the positive direction and the weight pointing to the negative direction. So the tension minus 412 is m1 times A. Now we repeat for block number 2. For block number 2, we have that the net force is equals to its mass times its acceleration. Notice that both blocks have the same acceleration because they move together. Then the net force acting on the second block is composed by two forces, the tension force and the weight force. But now the tension force points to the negative direction while the weight force points to the positive direction. So 908 minus T is equals to m2 times A. And then we have these two equations with two unknowns, which are the tension and the acceleration. We can calculate the masses using the weight force that was given and the acceleration of gravity, so it's not a big deal. Then we have to discover what is the acceleration. For that, notice that if we add this equation and this equation, the tensions will cancel. Therefore, let's do it. So adding equations number 1 and 2 results in the following equation. T minus 412 plus 908 minus T is equals to m1 times A plus m2 times A. Then, as I said, there is a cancellation of the tensions, and we get 908 minus 412 is equals to m1 plus m2 times A. Now, notice that the weight force is the mass times the acceleration of gravity, so the mass is the weight force divided by the acceleration of gravity. And then we can write it as 908 minus 412 being equals to weight number 1 plus weight number 2, and this whole thing is divided by G and multiplied by A. Then, this is 908 minus 412 equals to 908 plus 412 divided by G multiplied by A. Then we send these terms to the other side to get G times 908 minus 412 divided by 908 plus 412 is equals to A. Remember that G is approximately 9.8 meters per second squared. Then A is equals to 9.8 times 908 minus 412 divided by 908 plus 412. And this results in an acceleration of approximately 3.68 meters per second squared. So this is the acceleration of the system in the first situation and the answer for the first item. For the second item, let me organize my board. In the second situation, someone's pulling down the rope with a force of 908 newtons, and this produces a reaction force, which is the tension force. Therefore, in the second situation, the tension force is 908 newtons. Now, knowing this, we can calculate what is the acceleration of the lighter block in the second situation. For that, we have to use Newton's second law again. I'm choosing now this reference frame so that the net force acting on that block is given by its mass times its acceleration, but the net force is given by the tension minus 412. So 908 minus 412 is equals to the mass of this lighter block times its acceleration. So remember again that we can write the mass as the weight force divided by the acceleration of gravity. So 908 minus 412 is the weight force of the lighter block divided by g times a. And now we can solve this equation for a. So a is equals to g times 908 minus 412 divided by the weight of the lighter block, which is 412. G, we know that is approximately 9.8, so we have 9.8 times 908 minus 412 divided by 412. This results in an acceleration of approximately 11.8 meters per second squared. So this is the answer for the second item. So there is a difference between the acceleration. There is a huge difference actually. Why is this the case? This is the answer for the last item. So the reason is that before we had two masses, so we had more inertia on the whole system. In the second situation, we have only one mass, so we have less inertia on the second system. This is why the second system accelerates much more under the effect of a similar force.